third and final video on using and applying inverse trig functions. And to wrap it up, we're going to again look at our inverse sine, inverse cos, inverse tan, and via some examples we're going to look at 11. This one goes up to 11 examples, and from that hopefully be able to deduce some relationships, so some inverse type relationships or definitions. I might refer to them as definitions. Okay, so first example is there. If we had to, now the verbs to do if these are to do with the realm of calculate or solve, and by the way, these things are verifiable with a calculator. Because of the restricted domain, there is only one solution, and the actual answer on the calculator is reliable. But we're doing these by hand because that's important to be able to understand this. So the first one there, if you're given inverse sine of 2, and remember it's all radian measure, and you've got to solve that or calculate that, probably is a more appropriate verb here. You need a symbol, so it doesn't matter greatly what symbol you use. I'm going to use a mixture of x's and y's in this video. Let's try using x, so let x equal what we're given, so inverse sine of 2. Okay, so what we can do is take sine on both sides, okay, and when we get to here we run into some problems and we need to be analytical here. So there are no solutions to sine x equals 2, and we know that from our trig, periodic functions. We also know that based on earlier results that the valid inputs for inverse sine of x is limited to a domain of -1 to 1, and we have a 2 there, so there's actually no solutions to that. So no matter which way you look at it, there's no solutions. So we write no solutions we're looking at that 2 there, so we're talking about the domain there because elements of the domain have to be between -1 and 1. Okay, we've established that in the previous 3 videos, and 2 is not an element. Alright, 2 is not an element of the set from -1 to 1. I've also just deliberately uncovered an issue with using x. Now x in this one gets used in 2 different ways. Okay, so it's okay to use x. Trouble is we've got x in terms of elements of the domain, and I've also used it here to talk about elements in the range, and that could be a little bit ambiguous. So it's not wrong to use x, you just need a symbol, but I'm going to switch over and use y from here on for the rest of the video for the same job. So if we've got in example 2 inverse sine of -√3 on 2, let's try this. Let y equal inverse sine -√3 over 2, and we now can take sines of both sides. So we have sine of y on the left, and we have sine of inverse sine. Get used to writing lots of brackets. -√3 over 2. So we have sine y, got -√3 on 2 on the right. Now we have a think about our trig. So we know from basics that sine of pi on 3 is root 3 on 2. So for sine of negative pi on 3, we've got to think about our unit circle and the quadrants. And sine is positive in quadrant 1 and 2. Sine is negative in quadrants 3 and 4. It's a little sketch of that there below the unit circle. We're talking about these two angles here. Now if you think about, I urge you to think about what we're doing here. We're looking at possible values for this variable here. And look, we're dealing with sine of something, not inverse sine of it right here. So have a think. What are the restrictions on that variable? Okay, regardless of whether it's a symbol of x or y, you need to be aware of what we're dealing with. And so we're dealing with basically, if it's a simple trig equation, we've got the domain there. Okay, so remember, it can only, in this situation here, it's restricted from negative pi on 2 radians up to positive pi on 2. Okay, again, you could have used x's like in the previous one here, and that would just say x there, but the main thing is that you know the restriction on the domain. So that means that it's not possible to choose both of these answers, and we're only expecting one solution in each of these anyway. Okay, there's either going to be one solution or no solutions. And if you look at it, negative pi on 3 is suitable. It's in that restriction there, that's fine. So y equals, no matter what symbol, whether you use x or y or whatever, in this case for me y equals negative pi on 3 is a solution. What about 4 pi on 3? Well, 4 pi on 3 is this one here, and even if we wrote it, it's obviously too big to be within that top limit. Even if we wrote it as in the principal argument using the negative, it would be the same as negative 2 pi on 3. So that doesn't help at all, and that negative 2 pi on 3 is beyond the other end of that restriction. So that's the one and only solution. Example 3, a little bit harder now. So we've got y equals inverse sine of 13 pi on 2. And you might be thinking, oh, inverse sine and sine, and I'll just sort of cancel each other out. And we've got 13 pi on 12. Okay, I might have said on 2 just before at the beginning of the video, beginning of the segment. Sorry if I did. It's 13 pi on 12. So we can't just say that the inverse sine and the sine will just cancel each other out and you automatically got 13 pi on 12. There's more consideration that needs to go into it. So if we take sine of both sides, and we've got on the left sine of y. Now these two sines will yield together countering effect, and we're just left with that, provided we can justify it. And this is what I meant just before. We can't just say now y equals 13 pi on 12 automatically. We have to analyze it and then be able to justify our answer and get the correct answer. So a little sketch helps, I find, and 13 pi on 12 is anti-clockwise around to there. If you can see my cursor, okay. And so it's just a bit bigger than pi. 12 pi on 12 is pi, okay. Now we've got an issue here. We've got to consider our restrictions. This, in this case, y must be an element of the set from negative pi on 2 to pi on 2 radians inclusive, but it's not. 13 pi on 12 is not an element. Now is this like the first one we did where there's no solution? It pays to really stop and think. That should be a 2. this one might have a bit more to it. What I mean is that sine 13 pi and 12, does it have any equivalents that we can use? So if we look here, that would be pi on 12, and we can look at the geometric perspective of it, and remembering the little acronym ASTC, the mnemonic or whatever you use, we've got sine of 13 pi on 12 will be the negative of sine pi on 12, which also equals sine of negative pi on 12. And what we did was a very, very crafty little way of basically trying to get something that's equivalent. And why did I do that? Well, if we look at the restriction on the variable we're finding, on the domain in this case, for sine, the negative pi on 12 is in that restriction comfortably. So by using a geometric equivalence, and this one was a tricky one because we had to do it in 2 steps, we can find a suitable answer. So therefore y equals negative pi on 12 because we're chasing that. Okay, and because we were looking for y was the value of this expression here that we had to calculate a simpler value for, we have found what we are after. So we have calculated the value of inverse sine of sine 13 pi on 12, and it's surprisingly not 13 pi on 12, is it? It's negative pi on 12. Now pause the video and verify that with your calculator, and you'll find that regardless of whether you're using a CAS or non-CAS system, you will get something that is equivalent to negative pi over 12. Okay, so what I want you to do is enter this expression in its entirety, and you should get, to verify your answer, whether it's a decimal approximation or if you've got a CAS, the exact value, negative pi on 12. Go check that now. Okay, look, time for a break, and so this is an informal aspect of how I run things, and look, it doesn't really matter, but there were going to be 3 videos. I'm looking at the timer now. Let's take a break. There will be a 4th one to finish this off. In the next video, we will calculate the value of this expression here. In other words, solve it for a variable, and we'll come up with important generalizations. Very important video coming up. See number 4 coming your way very